Chapter 9, Lesson 5, Functions and their Inverses. To find the inverse of a function, we have to undo the function or find the opposite. This is where we switch the x and the y, and we solve for y. Given a graph, we can do the vertical line test to see if it's a function. The vertical line test, you draw the line up and down to see if it crosses more than one point. If it does not, then it would be a function. Given the original function, to see if the inverse is a function, we do a horizontal line test. In this case, if I were to draw a horizontal line, it goes through more than one point. So the inverse of this function is not a function. Do the horizontal test on the graphs below on your notes to see if they are functions. This would be yes, inverse is a function. No, the inverse is not a function because it goes through more than one line. Yes, this is a function, only goes through one point. No, not a function, goes through more than one point. The inverse of this last graph is a function, but the given graph is not a function. Find the inverse of this function. Again, this is the same thing that we have done in the past from chapter 7. We switch our x and y. So instead of writing y equals, I'm going to write x is equal to 1/2 y plus 2 squared. And I have to work backwards or undo the steps. To get rid of squared, I have to take the square root on both sides. When you're working backwards and you take a square root, you have to make sure to include your positive and negative numbers. We need both positive and negative because negative 2 squared is the same thing as 2 squared. So I have to subtract 2 from both sides. To get rid of 1/2 times y, I have to multiply both sides by 2. When I distribute this 2 in, and I give it to both terms, I can rewrite this as positive negative 2 times the square root of x minus 4 is equal to y, which is equal to the inverse a function of x. Determine if this new function is a function. What I'm going to do is I'm going to look back at the original equation. Since we have a squared here, this would be a parabola. So my graph would look something like this. So if I'm going to see if the inverse is a function, I'm going to do the horizontal line test. And since the horizontal line test shows me that it goes through more than one point, that means that the inverse is not a function. Also, I want to find the domain and range of this function. Whenever I have a square root, I cannot take the square root of a negative number. So my domain would be x has to be greater than or equal to 0, because I cannot take the square root of a negative number. My range is typically going to be all real numbers, meaning whatever number I put in, I will be able to get out. And I can rewrite all real numbers that has a double line and then an R. So attempt the next question by yourself. To find the inverse, I'm going to put x is equal to y cubed minus 2. First, I have to add 2 to both sides. To get y all by itself, I have to take the cubic root. Now, the cubic root can have negative numbers because negative 2 cubed will give me a negative 8. I want to determine if the inverse is a function. If I were to draw a sketch of a cube function, it looks something like this. If I do my horizontal line test, no matter how I draw my horizontal line, it will just go through one point. So then the inverse is a function. I also want to state the domain and range. Since this is a cubic root, whenever you have an odd root, cubic root, the fifth root, seventh root, your domain will be all real numbers because all of your negative numbers are included. And range is also all real numbers. Any number that you put in, you'll be able to get any number out. So now we're going into, we want to see if the function of f and the function of g are inverse functions. To do this, we have to find fog. Fog is the function of g inside the function of f. So when I write this out, wherever I see an x right here, I'm going to replace it with the function of g. So I want to simplify this. I distribute my 2 in. 2 times 1/2 will give me 1, which is just x. 2 times negative 4 will give me negative 8. X minus 4. This is my simplified version. If I would have gotten x out, then these two functions would be inverses. Since I did not get x out, that means no, they are not inverse functions. So here are my next two problems. The key is looking at x is greater than or equal to 0. If they did not have x is greater than or equal to 0, this would be a different situation. But since they stated x has to be greater than or equal to 0, I have to test fog. If fog is true, then I will have to test goff. I have to get x out for both equations. So if I put the function of g in the function of f, so I'm going to start writing the function of f. I've seen x right here, so I replace that with 2 square root x squared, and I simplify. When I have a power on the outside, I have to make sure to give to everyone on the inside. So this would be 1/4. 2 squared would be 4. Square root of x squared will just give me x. When I multiply the 1/4 times the 4, that'll give me 1x, or just x. So now since this simplified to be just x, I have to check goff. So I start writing the function of g. Anytime I see an x, I write my function of f. So it'd be square root of 1/4 x squared. Since these two are being multiplied right here, I can split those two up. So this would be the square root of 1/4 times the square root of x squared. This can also be split up, if you don't see it right away, the square root of 1 over the square root of 4. So the square root of 1/4 would be equal to 1/2. Square root of 1 is equal to 1, and the square root of 4 is equal to 2. Square root of x squared will just give me x. If I simplify, I just get x out. So this would be, yes, they are inverse functions. And finally, test these last two equations to see if they're inverse functions. First, I test fog. So I start writing the function of f. Wherever I see an x, I replace that with the function of g. I'm going to distribute my 2/3. 2/3 times 3/2 will just give me x. 2/3 times 9/1, or negative 9/1. My 3's will cancel. Oh, this would just be 1. So 2 times negative 3 will give me a negative 6. Negative 6 plus 6 gives me x. So now I have to make sure that GOF reduces to x. So I start writing my function of g. Wherever I see my x, I replace it with the function of f. So I distribute my 3/2. I get x 3/2 times 6 reduces to plus 9 minus on the outside. Since I have both x simplified, it'd be yes. They are inverse functions. Homework is on page 693, 1 through 13, 33 through 35, 59, and 61. 12 minutes only.